Welcome to this video. We're on page 31 of our notes. We have three tables that show the different velocities of an object at different moments in time. Part A says, in which datasets is there acceleration? Before you try to answer Part A, recollect the definition of acceleration. It's how much the velocity changes per second. That's sort of an informal definition, but it's what I think about when I think of acceleration. I think, how much does velocity change per unit time, per second? Well, the only way you can accelerate is if your velocity changes. In table 1, is the velocity changing? Yes, so there's acceleration. In table 2, is the velocity changing? Yes, therefore we have acceleration. In table 3, is the velocity changing? No, it's always 2 meters per second. So that's how we know 1 and 2 have acceleration. Part B asks, in which datasets is the acceleration constant? Okay, constant acceleration. That means as we step forward in time, as this increases, as we move forward, we need to add the same amount, or we need to subtract the same amount. In other words, this delta V must be consistent or constant. That's how we get acceleration to be constant. Well, look over at table 1. From 0 to 1 seconds, we've changed our velocity by positive 2 meters per second. And then from 1 to 2 seconds, we changed our velocity again by positive 4. From 2 to 3 seconds, we changed our velocity once more by positive 6. And you see what's happening. We are not being consistent in our delta V. The delta V is not constant. Therefore, acceleration is not constant. How about table 2? Here, from 0 to 2 seconds, we add 4. That's our delta V. From 2 to 4 seconds, the delta V is positive 4 again. From 4 to 6 seconds, the delta V is positive 4. Again, we went up 4. And you guessed it, here we've also added 4. So yes, that is constant acceleration, because delta V is constant. Now you might argue that this one is constantly adding 0, so that's constant acceleration too. And you would be valid. You could put 3 as well, or you don't have to. Both would give us the full credit. Last question. In which datasets is the object not moving? Now you might rush and put 3 as an answer, but that would be wrong. Because here's the thing. They're still moving. They have a velocity. They're walking at the same steady pace, 2 meters every second. Every second they move 2 meters forward. They're just not getting faster or slower. So they're still moving in dataset 3. In fact, not moving would mean the velocity is 0. And that's not the case in any of these datasets. They have motion in every single dataset because V is not 0 in any set.